Hello, my name is Ahmad and today I'm going to be explaining to you some trends in the periodic table. Ionization energy is the energy required to remove an electron from an atom or an ion. As you move down a group, the ionization energy increases, and that is because each element has more occupied energy levels than the one above it has. And as you move down a group, each successive element contains more electrons in the energy levels between the nucleus and the valence electrons, and this electron shielding causes the valence electrons to be held less tightly to the nucleus. And now as you move from left to right, the ionization energy increases, and that is because as you move across a period, the number of protons and electrons increases. The increasing number of protons increases the nuclear charge, causing more attraction with the valence electrons. Thus more energy is required to remove an electron because the attractive forces on them is higher. Electronegativity is a chemical property that describes the tendency of an atom to attract a shared pair of electrons towards itself. As you move down a group, electronegativity decreases, and that is because from one element to the next in a group, the principal quantum number increases by 1. So another principal energy level is occupied. The more protons an atom has, the more strongly it should attract an electron. Therefore, you might expect that electronegativity increases as you move down a group. However, electron shielding plays a role again. Even though cesium has many more protons than lithium does, the effective nuclear charge acting on the valence electron is almost the same in both atoms. But the distance between cesium's 6th principal energy level and its nucleus is greater than the distance between lithium's 3rd principal energy level and its nucleus. This greater distance means that the nucleus of a cesium atom cannot attract a valence electron as easily as a lithium nucleus can. Because cesium does not attract a valence electron as strongly as a lithium atom, it has a smaller electronegativity value. As you move from left to right, the electronegativity increases. That is because of increasing number of protons. The effective nuclear charge increases as you move across a period because of the increasing number of protons. And as this increases, electrons are attracted much more strongly, resulting in the increase of electronegativity. One way to measure the size of an atom is by calculating the bond radius, which is half the distance from center to center of two like atoms that are bonded together. As you move down, atomic radius increases, and as you move down a group, another energy level is filled, thus increasing the size of the atom. The electron shielding also plays a role with the valence electrons, making them not pull closer to the nucleus. As you move from left to right, atomic radius decreases. As you move from left to right, all additional electrons go into the same principal energy level. As a result, electron shielding does not play a role. The increasing nuclear charge pulls the valence electrons closer to the nucleus, thus reduces the size. Ionic radius is the distance between the nucleus and the valence electron of an ion. As you move down cations, the atomic radius increases due to the increasing number of energy levels. But the cation is smaller than the parent ion due to the loss of the valence energy level. Also, as you move down anions, the atomic radius also increases due to the increase in number of energy levels. But the anion is larger than the parent atom due to the increase in the number of electrons, thus causing repulsion in the energy level. As you move from left to right, cations atomic radius decreases due to the increase in protons and the increase in effective nuclear charge. That is the same for anions, but between them the atomic radius increases and then goes back down. So when you start in cations, it's big and then goes to smaller and smaller and smaller, but still in cations. Then when you go back to anions, it goes back to like big and then gets smaller and smaller and smaller. So between them, it goes from small to big. Electron affinity tells you the energy change that occurs when an electron is added to a gaseous atom. It is the opposite of ionization energy. As you move down, electron affinity decreases because the distance between the valence electron and the nucleus increases due to the increase in energy levels. This leads to lesser affinity of electrons towards the nucleus, which leads to lesser energy being released when an electron is added. As you move from left to right, electron affinity increases because the size decreases, so the nuclear pull on the electrons increases, so the affinity of electrons towards the nucleus increases too. Metallic trend is how readily an atom can lose an electron. Metallic trend increases as you move down a group because the atomic size is increasing. When the atomic size increases, the outer shells are further away. The principal quantum number increases and average electron density moves further from the nucleus. The electrons of the valence shell have less attraction to the nucleus and as a result can lose electrons more readily. This causes an increase in metallic trend. But as you move from left to right, metallic trend decreases because the attraction between valence electrons and the nucleus is stronger, enabling a harder loss of electrons. Shielding effect is when inner electrons shield outer electrons from the full attractive force of the nucleus. As you go down a group, electron shielding increases because of the addition of extra energy levels as you go down. More energy levels means more shielding. And as you move across a period, electron shielding stays the same because all of the elements in a period will have the same amount of energy levels. Effective nuclear charge is the attraction of the protons in the nucleus on the valence electrons in an atom. As you move down, the nuclear charge increases but is overwhelmed by the greater shielding effect, which will cancel out the effective nuclear charge, causing it to decrease moving down a group. Moving across a period from left to right, effective nuclear charge increases because more protons are being added, but electron shielding is staying constant. Coulomb's law is a law that states that two like charges repel and two opposite charges attract. It also states that the force of attraction between two opposite charges is proportional to the strength of those charges and inversely proportional to the square of the distance between them. This is also shown by the formula on the board, where d is the distance between the charged particles, q1 represents the quantity of charge of one particle, and q2 represents the quantity of charge of the other particle, and k is Coulomb's constant, which is 9.0 times 10 to the power of 9. Like all other forces, the electrostatic force between two charged objects is measured in newtons. And if F is negative, it equals attraction, and if F is positive, it equals repulsion. This was Ahmad, and I hope you really enjoyed and learned a lot from this presentation. Thank you for listening.